Hello students, now we'll be solving memory-based question of GATE 2019. For more video solution on GATE 19, subscribe to our channel and don't forget to click bell icon for instant notifications.
Hello students, my name is Pranshu Mahajan, and in this video we are going to discuss a question of heat transfer and particularly for steady state one-dimensional heat conduction. Okay. Though it appears to be a question of cylinder, so many of us might get confused with radial heat conduction, but actually it is written in the question only that we have to neglect radial heat transfer. This means the heat transfer is along the length of the cylinder. Okay. So let's have a look at the question, and some options are also given. So firstly we will read out the question and then we will solve it. A cylindrical rod of length L and diameter D, where L is much greater than D. Okay, L is much greater than D. So basically this is a cylinder rod, and thermal conductivity K1 is joined with another rod of same dimension. So basically there is one more rod which has same diameter D, same length L, but thermal conductivity is different, K2, to form a composite rod of length 2L. So basically it's like this. There is a rod of thermal conductivity K1, there is a rod of thermal conductivity K2, and they are joined end to end. Then only the total length will become 2L. So what I can say is that now I have a rod of length 2L, but it has a non-homogeneous material. So half portion has material K2 and half portion has material K1. Now what they are asking is, assuming heat transfer in radial direction. So I think if we consider this as the rod, this will be the periphery of the rod, circumference of the rod, and this will be the radial direction. So what they are saying is we have to neglect the heat in the radial direction. So only heat possible is along the length of the rod. So basically this will be the high temperature maybe, and this will be the low temperature. Okay. So what they are asking is neglecting the heat transfer in radial direction and neglecting any contact resistance. So this is a contact. We have to neglect the contact resistance. Find out the equivalent thermal conductivity of the composite rod. So I think when we say equivalent, so equivalent means you have to replace this body of non-homogeneous material by a body of homogeneous material such that the thermal resistance remains the same. Okay, so we are taking an imaginary composite body which has homogeneous material, and thermal conductivity of that imaginary body will be called as equivalent thermal conductivity. Okay, so I think we are going to use the concept of thermal resistance over here. So we have to find out which options is correct. Actually it's an MCQ question. So let's solve the question now. Okay friends, so let's have a look at the solution. So I think this is the situation given to us. There are two rods. Both the rods have same diameter, same area of cross section, and the lengths are also same, that is L. So basically this length is L. Now the two rods are joined end to end. So this will be the situation, and the new rod will have a length 2L. Now what they are saying is we have to neglect the radial heat transfer. That means the heat transfer is along the length of the rod. It is longitudinal. And what we want to do is we want to find out the equivalent thermal conductivity of the composite system. So equivalent thermal conductivity means we want to replace this body of total length 2L and diameter D and non-homogeneous material with the body of homogeneous material, but its diameter will be D and the length will be 2L. So I think thermal resistance of this composite system and thermal resistance of this equivalent system are going to be same. Let us write down the thermal conductivity of composite system first. So I think in longitudinal heat transfer, there will be two bodies, but this will be a series connection, right? Heat will flow in the body 1 first, then the same heat will go into the body 2. So this means this is a series connection. So what I have written is for longitudinal heat conduction through the composite system, total resistance will be resistance of part 1 plus resistance of part 2. Now I think we have a body of uniform cross section. So resistance will be L upon Ka. So this will be L1 by K1A1 plus L2 by K2A2. Sorry, this is A2. But I think length of both the bodies are same. Areas of both the bodies are same. So L by A, that will be a common. So this will be your total resistance. Now for the equivalent system, you can write down the resistance to be 2L upon Ka, where K is nothing but actually it is K equivalent. Now these two resistances have to be equal. So what you will say, 2L by K equivalent A is equal to L by A upon 1 by K1 plus 1 by K2. I think L by A, this is common. It will cancel out. You will take all the terms on the other side to bring K on one side. And when you will take K here and remaining terms here, you will have K is equal to, I think this will become 2 upon 1 by K1 plus 1 by K2. You can simplify it by taking LCM. So K2 will go here, K1 will go here. So this will become K1 plus K2. And this denominator K1, K2 will go upstairs. So this will become 2 K1, K2 upon K1 plus K2. So this is the final answer. This is the equivalent thermal conductivity, that is 2 K1, K2 by K1 plus K2. So you can find out the answer from the options. This is the correct answer. So I hope you like the solution, and this solution might help you and your friends also. So please like the solution and share it with your friends. Thank you. Thank you very much.